In this video, we shall look at integrations of trigonometric functions. In particular, we shall look at integral of this particular type. Sine to the power m theta and cosine to the power n theta. And we shall integrate that with respect to theta. Now, as you can see, the integrand is a product of powers of the sine and cosine of the variable of integration. To evaluate an integral of this kind, we notice for the present the following methods. Essentially, these are methods of substitution. So, number one, if n, which is the power of cosine, is odd, so it's an odd number, then the following substitution would work. We shall substitute, say, v to be sine theta, which implies dv to be cosine theta d theta. This also implies that cosine squared theta to be 1 minus v squared, directly from trigonometric identity. Second possible substitution, if m is odd, namely the power of sine is odd, then the following substitution could work. We could substitute v for cosine theta, which then implies dv, or the differential of v, to be minus sine d theta. V being cosine theta implies sine squared theta to be 1 minus v squared. Case number 3. M and n are both even. They are even numbers. For this case, we should just apply the double angle formula of trigonometry, namely cosine squared theta equals half 1 plus cosine 2 theta, or sine squared theta equals half 1 minus cosine 2 theta, or the product of cosine theta sine theta being half sine 2 theta. So when both indices are even, these double angle equations may prove useful. Now let's do a few integrals to illustrate these rules. Integral number 1, you want to integrate that. We note that the power of sine is odd, so according to the rules that we have just discussed a few minutes ago, we can try the following substitution. V being cosine theta, or the differential of v is minus sine theta d theta. So first let's call this integral j. So let's rewrite j a little bit. So it's essentially sine squared theta times sine theta d theta. And you see that with this substitution, sine squared, which is just 1 minus cosine squared, is just in terms of v, becomes 1 minus v squared. And sine theta d theta from that differential is just minus dv, which is just v squared minus 1 dv. And we know how to solve this. It is just 1/3 v cubed minus v plus an integration constant. Since v is cosine theta, right there, rewriting this result in terms of cosine, you get 1/3 cosine cube theta minus cosine theta plus integration constant. And this is the final result. What about this integral? You see that the power of cosine now is odd, so we could try the following substitution, v being sine theta, and that means dv is cosine theta d theta, and that also means cosine squared theta is 1 minus v squared. So let's rewrite I in the following manner. Cosine squared theta, cosine theta d theta. And this is just cosine squared is 1 minus v squared. Cosine theta d theta from that line is just dv. And we know how to integrate this. It's just v minus 1/3 v cubed plus an integration constant. Let's call it d. Substituting back the expression for v, which is sine theta, you get sine theta minus 1/3 sine cubed theta plus the integration constant. And that's the final result. What about this integral? Let's call it j. Both the powers are even, so the double angle formula should work. The double angle formula states sine theta cosine theta is half sine 2 theta. Substituting this information inside of j, we get 1/4 sine squared 2 theta d theta. But we also know sine squared, let's say x, can be written in terms of cosine 2x in the following manner. Half 1 minus cosine 2x. So j then becomes 1/8, because this is 1/4 times 1/2 is 1/8, integral of 1 minus cosine double that angle, which is 4 theta d theta. This can be solved easily. 1/8 integrating 1 with respect to theta, you get theta. Integrating cosine 4 theta with respect to theta, first you differentiate 4 theta with respect to theta, you get 4 and you write it below. Then integrating cosine, you get sine 4 theta plus an overall integration constant c. And that's the desired result. Let's look at this integral. The power of sine is odd, so we can use the following substitution. V equals cosine theta, so therefore dv is minus the sine theta d theta. So let's realize that sine to the power of 5 is just sine to the power of 4 times sine theta d theta. And by now, using the trigonometry identity, we know that since v is cosine theta, sine squared theta is 1 minus v squared. But here there is a 4, so it is just a square of 1 minus v squared. Now the remaining term, sine theta d theta, from here is just minus dv. Expanding the bracket, we get 1 plus v to the power of 4 minus 2v squared dv. Remember, I've taken this minus sign out of that integral sign. And this we know how to do. Integrate 1 with respect to v is just v. Integrate v to the power of 4 is 1/5 v to the power of 5. Integrating v squared, you get 1/3 v to the power of 3 plus an integration constant. And finally, it simply becomes, using the fact that v is cosine theta, it is just minus cosine theta minus 1/5 cosine to the power of 5 theta plus 2/3 cosine cube theta plus integration constant. And that is the final result. Next, let's look at this integral. We see that the power of cosine is odd, namely 1. So let's use the following substitution. V equals sine theta. So dv is cosine theta d theta. So the above integral will become dv over the square root of sine is just the square root of v. So if you integrate v to the power minus half, this becomes v to the power half over 1 over 2, which is 2 square root v. And the answer here is therefore 2 square root v plus an integration constant. Putting back the expression for v, you get 2 times the square root of sine theta plus the integration constant. And that's the result. Now let's look at this integral. Now, the numerator is cosine, and the power of that cosine is 3, which is odd. So the substitution that we can try is v equals to sine theta, and dv is cosine theta d theta. Now rewriting the above integral a little bit as cosine squared theta times cosine theta d theta over sine to the power of 4 theta, and remembering the fact that cosine squared theta in terms of v is just 1 minus v squared. Putting everything in here, we get the following in terms of v. So cosine squared is just 1 minus v squared. Cosine theta d theta from here is just dv. Sine to the power of 4 is just v to the power of 4 from the substitution, which is integrating v to the power minus 4 minus v to the power minus 2 with respect to v. Now that is just minus 1 over 3 v to the power minus 3 minus v to the power minus 1 plus an overall integration constant. The earlier two minuses will give you a plus, and you end up with that result. And rewriting the answer in terms of theta, using the fact that v is sine theta, we get minus 1 over 3, 1 over the sine to the power 3 theta plus 1 over sine theta plus the integration constant. And this is the final answer. Let's look at this following problem. The power of cosine is odd, so we can try v equals to sine theta. So dv is cosine theta d theta. Recognizing the fact that I can be written as sine squared theta, cosine squared theta, cosine theta d theta, in terms of v, it simply becomes v squared 1 minus v squared for cosine squared, and cosine theta d theta is just dv, and this is just v squared minus v to the power of 4 dv, which we can easily solve to be 1/3 v cubed minus 1 over 5 v to the power of 5 plus an integration constant, substituting the v as sine, so it becomes 1/3 sine cube theta minus 1 over 5 sine to the power of 5 theta plus integration constant, and that's the answer. Now let's look at this integral. Because the power of cosine is odd, one could suggest v to be sine theta, but then the term in the bracket is 2 plus sine theta, so that would suggest to take v to be 2 plus sine theta instead, because that does not change the differential. dv is still cosine theta d theta. So writing the integral now in terms of v, you have v cubed dv, which is just 1 over 4 v to the power of 4 plus an overall integration constant. Now substituting back the expression for v, you get 1 over 4 2 plus sine theta to the power of 4 plus integration constant c, and that is the final answer. As always, if you find this video helpful, please don't forget to like, share, and subscribe for notifications on more videos such as this one. Thank you for watching.